Have you ever looked outside and thought, this weather is just plain weird? Maybe you've seen snow falling in places where it almost never snows, or felt a warm breeze in the middle of January and wondered if the seasons had gotten mixed up. In the winter of 2026, people everywhere were saying exactly that. From bustling city streets to quiet rural towns, conversations turned to the sky, as everyone tried to make sense of the strange conditions unfolding around them. It was a season of wild contrasts. While Paris froze under a thick blanket of snow, Greenland's ice was melting in January, a time when it should have been solid and unmoving. This wasn't your typical winter. It made headlines across the globe and left everyone asking, what's going on with our weather? Meteorologists scrambled to explain the bizarre patterns, and social media buzzed with theories and questions. In some places, people bundled up against record cold, bracing themselves against icy winds. In others, they wondered where the snow had gone as lawns stayed green and streets remained clear. The United States was split, one half buried in snow and ice, the other basking in spring-like warmth. It was as if the country had been divided by an invisible line, with winter on one side and early spring on the other. News showed frozen fountains in Rome, skiers gliding down London streets, and satellite images of Greenland's ice sheets shrinking when they should have been growing. It was a powerful reminder. Our planet's weather is deeply connected, and a change in one region can set off a chain reaction across the globe. What happens in the Arctic can ripple across continents, affecting millions of people, from city dwellers to farmers, and even wildlife struggling to adapt. This winter was a dramatic example of that, with storms and temperature swings that seemed to defy logic and expectation. So, why did it happen? Scientists point to powerful forces high in our atmosphere, forces that can shift suddenly and send weather patterns spinning out of control. Think of it like a spinning top that suddenly wobbles, causing chaos in every direction. When the balance is lost, the effects can be felt far and wide. In the next sections, we'll explore the polar vortex, sudden stratospheric warming, and the jet stream. Three key players in this winter's wild ride. Let's dive in and uncover the science behind the wild winter of 2026, and see how these invisible forces shape the world we live in. The puzzle pieces are about to come together, revealing a story of weather, science, and the surprising power of our planet's atmosphere. Let's break down the polar vortex, a term you might have heard in the news, but what does it really mean? Picture a giant spinning top of icy air swirling high above the North Pole each winter, stretching for thousands of miles. This swirling mass is held in place by powerful winds, acting like an invisible fence that keeps the coldest air trapped near the pole. When the vortex is strong and stable, the cold stays put, and winters in the mid-latitudes are relatively predictable and mild. But if something disturbs this balance, like a sudden warming event or a shift in atmospheric patterns, the vortex can weaken or even split apart, and that fence starts to break down. That's when frigid Arctic air escapes, plunging southward into North America, Europe, and Asia, bringing sudden and severe cold snaps. It's not a single storm, but a breakdown in the system that usually keeps the cold contained, leading to unpredictable and sometimes dangerous winter weather. In 2026, the polar vortex didn't just wobble, it was knocked dramatically off balance, unlike anything seen in recent years. Something significant happened high in the atmosphere, setting off a chain reaction that would affect weather patterns across the globe. The result? Extreme cold snaps, wild winter storms, and heavy snow in places that rarely see it, all far from the Arctic Circle. The polar vortex was the first domino to fall, setting off a cascade of winter chaos. Next, we'll explore what powerful force triggered this dramatic wobble, and how scientists pieced together the clues. The story of the winter's chaos starts here, with the unraveling of the polar vortex. Let's find out what happened next, and how this rare event changed the course of winter for millions. What could possibly disrupt the mighty polar vortex, that swirling mass of cold air locked high above the Arctic? For most of the winter, it spins undisturbed, keeping frigid air trapped at the top of the world. But sometimes, something extraordinary happens. Enter sudden stratospheric warming, or SSW. High above the ground, in the stratosphere, temperatures can suddenly spike by as much as 50 degrees Celsius in just a few days, a dramatic and almost unbelievable shift. This rare phenomenon is like a shockwave rippling through the upper atmosphere. SSW happens when giant atmospheric waves, generated by mountains and weather systems far below, surge upward and break, releasing huge amounts of energy. This rapid warming acts like a hammer, pushing down on the polar vortex, distorting its shape or even splitting it into pieces. The result? The once contained cold air escapes the Arctic's grip, spilling southward into regions unprepared for such a deep freeze. In early 2026, a major SSW event unfolded, and scientists immediately recognized that big changes were on the horizon. The effects of SSW don't reach the surface right away, but when they do, weather patterns across the Northern Hemisphere can shift dramatically for weeks on end. This SSW was the key that unlocked the Arctic's freezer door, sending waves of cold far and wide. The stage was set for a winter of extremes: blizzards, deep freezes, and wild swings in temperature. But the story doesn't end here. The next link in the chain? The jet stream. Let's see how the jet stream delivered chaos around the world. The atmosphere was about to get even stranger, and the consequences would be felt everywhere. With the polar vortex off balance, the jet stream became the main delivery system for chaos. The jet stream is a fast-moving river of air high above us, separating cold from warm. Normally, it flows in a steady path, keeping weather predictable. But when the vortex weakens, the jet stream turns wavy and erratic. Deep dips pull Arctic air south, causing cold snaps and snowstorms. High ridges push warm air north, bringing thaws to frozen places. In 2026, Europe and the western US were stuck in cold troughs, while Greenland and the eastern US basked in warmth. This stuck, wavy pattern lasted for weeks, creating wild contrasts. The jet stream's meandering was the engine behind the season's extremes. Weather became a game of chance depending on which side of the wave you were on. The jet stream's wild ride defined the winter. Next, let's see how it played out on the ground. Europe faced a relentless deep freeze as Siberian air swept in. Cities like London, Paris, and Berlin stayed below freezing for weeks. Energy grids strained, travel ground to a halt, and daily life was upended. Farmers worried about crops and livestock, while emergency services battled burst pipes and icy roads. The cold tested the continent's resilience, exposing vulnerabilities in infrastructure. Picturesque snow scenes hid real economic hardship and disruption. The beast from the east was more than a headline. It was a harsh reality for millions. This winter showed how a shift in the Arctic can bring Europe to a standstill. Nature's power was on full display. While Europe froze, Greenland experienced a shocking winter heat wave. Warm air surged north, trapping heat over the ice sheet. Temperatures soared over 30 degrees Celsius above normal, near melting point. For the first time, meltwater rivers formed on the ice in January. Scientists were alarmed. This was Arctic amplification in action. The loss of winter ice is a warning sign for global sea levels and climate stability. Local Inuit communities faced dangerous travel and disrupted hunting. Greenland's winter melt was a climate alarm bell, ringing loud and clear. The Arctic's changes are everyone's concern. In the US, the jet stream split the country in two. The West endured relentless cold and snow, while the East enjoyed spring-like warmth. Denver and Salt Lake City were buried in snow. Farmers and ranchers struggled. Meanwhile, Boston and Atlanta saw mild weather, early blooms, and confused wildlife. Ski resorts in the East suffered, while those in the West thrived. The natural world was thrown off balance. This dramatic split showed how a wavy jet stream can create two winters at once. The winter of 2026 was a lesson in weather's unpredictability. America experienced both extremes, sometimes just a state apart. The atmosphere's chaos was impossible to ignore. Some see a deep freeze and doubt global warming, but scientists say it's all connected. The Arctic is warming faster than anywhere else, disrupting the climate system. As the temperature gap between Arctic and South shrinks, the jet stream weakens and wobbles. This leads to more stuck weather patterns, prolonged cold, heat waves and droughts. A warming Arctic can actually cause more intense cold spells elsewhere. Climate change isn't just about rising temperatures, it's about greater instability. The winter of 2026, the winter for 2026, is a preview of a future with more extremes. The cold in Europe and the melt in Greenland are two sides of the same coin. The pattern of weirdness is exactly what scientists have warned about. What does the wild winter of 2026 mean for our future? As the season ends, Europe faces flooding from the thaw, and the US prepares for more unpredictable weather. The bigger lesson: our climate system is sensitive, and our actions have far-reaching consequences. Record low Arctic sea ice. This winter could mean even more instability ahead. The warmth in Greenland and the cold in Paris are linked. Our atmosphere is one interconnected machine. This winter was a wake-up call. Normal weather is becoming rare. We must understand and address the root causes of climate change. Studying extreme seasons helps us prepare for a more unpredictable world. The weird winter is over, but its lessons are just beginning. Our future depends on what we do next.